All right, here we have our Desmos graphing calculator. I just wanted to show you guys really quickly how you can use it to check your transformation rules. If we start with our parent function f of x equals x cubed, and you want to see what happens to your graph when you multiply by 1/4. Now this 1/4 is not in parentheses with x, okay? It's outside of the parentheses. It's not in parentheses with x, so it's a vertical compression times 1/4. So if I graph that function, hopefully you can see that blue graph has kind of been squished vertically, right? It's a vertical compression. Now, if you look at that g of x, and then the next function I have is h of x, and you'll notice hopefully that there is not parentheses. So I'm looking at lines 2 and 3 of my typed equations. H of x, there are no parentheses around this x variable. So watch what happens when I graph this function. The green function is on top of the blue function I just graphed. So because there was nothing being added or subtracted or multiplied to my x variable, it doesn't really matter if I have parentheses around the x variable or not. The only thing that matters is if I'm multiplying an x variable by something, then that number would have to be in parentheses with x. Okay, so let me turn off the blue and the green. So again, here's our parent function. What happens if I multiply my x variable by a negative? Like at this purple graph. And remember, anytime you multiply your x variable by a negative, those x values reflect across the y-axis. But now look at problem number 5, where it says k of x equals negative x to the third power. Okay, this one's tricky. It's not in parentheses with x, so it's changing my y variables. My y variables are reflecting across the x-axis. So watch what happens. When I graph that function, the purple and the black function look exactly the same. And I know we're splitting hairs here. When you have a polynomial function that is odd, when the degree is odd, a vertical reflection and a horizontal reflection, a reflection across the y-axis and a reflection across the x-axis, they look exactly the same. So it's important that you understand those rules, okay? However, let me show you this. If we are working with y equals x squared, so this is an even function, okay? It's symmetric with respect to the y-axis. If I multiply inside the parentheses my x variable, okay, that's going to reflect across the y-axis. So watch what happens. I took that red graph and it reflected across the y-axis, which basically looks exactly the same. But what happens if I multiply the y values by a negative? Okay, so that negative on row 8, y equals negative x squared with no parentheses, that's changing my y values. So watch what happens when I graph that. That one reflects across the x-axis. My y values reflect across the x-axis. So your reflection rules are a little bit tricky, and I just wanted to point that out to you. But the shifts are really easy to see. So if I have y equals x squared, and let's start with y equals parentheses, let's do x minus 2, close parentheses, squared. You can see that your graph shifts to the right 2. It's the opposite operation. Anytime you mess with your x variable, it does the opposite. But if I changed that to, let's say, y equals parentheses x plus 4 squared, you can see your graph shifts left 4 units, okay? So translations are really easy to tell. So if you're trying to check a translation or a shift, those are pretty easy to see. Let's try something else. Let's do a vertical translation. We could do y equals x squared plus 6. You can see how your graph shifted up 6 units. You also could have done y equals x squared minus 3. There you see your graph shifts down 3 units. So Desmos is a really handy tool to double check your transformation rules. I just want you to be careful with those reflection rules, okay? You've got to remember which is which. All right? Happy mathing.